Hello everyone, this is Tamaskan from Skill Lab. Today we are going to see beam analysis tutorial. What we are going to do is we are going to solve shear force and bending moment diagrams in SOLIDWORKS. So here we have the beam. As you can see, there is point A here, point B, point C and point D. So at point B and at point D, the beam is supported. So at point B it's pin supported, at point D it's roller supported. So when we say roller, it means there is only this force, and when we say pin, there is this force, and also there is a force that comes this direction. So we are going to solve this thing in SOLIDWORKS. At the same time, we also have force 30 kN and 50 kN at point A and at point C. So let's go immediately to SOLIDWORKS and let's create this frame first. And after that, we will go step by step into drawing the shear and the bending moment diagrams. So here we have SOLIDWORKS, and let's sketch front plane. One thing that I want to tell you is, as you can see, we have point A and point B. We'll take it as one line. Point B up to point C, the second line. Point C up to point D, the third line. So here we have the first line, the second line and the third line. This one is point A, point B, point C, point D. I forgot, sorry, we have to convert this one. It's inch now, so we have to convert to meter. So let's edit our dimensions. This one is, we'll edit it first. Let's make it like this. Let's go to our PowerPoint. This one is 1 meter, 3 meter and 2 meter. Okay, this one is 1 meter, this is 3, and the last one is 2. 1, 3, 2. Cross check. Yeah, 1, 3, 2. After you do this, let's just exit and let's go to weldment. This thing. If you don't have this thing in your SOLIDWORKS, just what you are going to do is click right here, right click, and you have tabs here. You can just scroll and you can check this weldment. So we have structural member, and then let's just select this one and let's make like this. So we don't need this. Like, the thing that really interesting is here, SOLIDWORKS doesn't care about this. So what we are going to do is, let's just delete this sketch. In order to draw the shear force and bending moment diagram, we don't have to worry about this. Let's just sketch this thing. Let's make like this. And before we go into our simulation, what I want to say is, here, let's right click this plane and normal to. As you can see, it is in the Z and X direction, right? So we are going to apply our load here in the upward. So we have to make sure that, let's make this Y and let's make this X, right? In order to make this, let's go to this, right click and edit feature. Let's go to this thing and let's make 90 degree. Rotate, right? So let's check it. You can see Y and X. The thing, why we are doing this is, after we simulate our beam, it should have to be in the Y and Z direction in order to make it easily understandable. It doesn't have any reason. This is the reason. I think we finished this part, so let's proceed to simulation. The same thing here. If you don't have simulation tab, you can find it in this SOLIDWORKS add-in. So after you click this, it will appear immediately right to the SOLIDWORKS add-ins. So let's go simulation, new study, and here we have beam analysis. Right click. Yeah, so this is what I was saying. Here we have point A, here we have point B, here we have point C, and here we have point D. After that, we are going to apply the supporters, right? Point B and point D. So let's go. But before that, in manual calculation, we don't assign material, right? But in order to proceed into our simulation, SolidWorks wants us to assign a material. So right click here and apply material to all bodies. So as you can see, we have alloy steel, as simple as that. Right click. So you can see there is a green arrow right here. It means you already selected material. So let's go to the fixtures and right click and fix geometry. So here we have, this is the joint, right? So here we have one reaction force. Select this joint and let's go. It's gonna be across the front plane, right? Let's check this. You can see, right? So as I told you before, we have one supporter and also we have this. So in order to make it visible, let's increase the size of the symbol. Maximum is 500. Yeah, this is our support. So right, and the other supporter is roller at point D, at the end, at this end, right? So let's add this fixed geometry. Let's go through this and let's select this joint across what? Across front plane. And then as I told you, it's roller, so we only have this one. And to make it more visible, let's increase the size of the symbol, which is 500, the maximum one. So this is the second step. We assigned our reaction forces. So let's go, or let's apply the force. Here we have 30 kilonewton, here we have 50 kilonewton. At point A, let's go to force, and as I told you, this is still joint, right? This is point A. Let's select the joint, this one. Yeah, sorry. And let's go to the front plane. And then here we have this force. As you can see, it is in the opposite direction, but we have to reverse it. How much is it? 30,000. 3. Let's increase the symbol to make it more visible. This is 500, just to make it more clear. So we have this downward force, which is 30 kilonewton, right? Yeah. And then let's go to point C and let's apply the 50 kilonewton force. Okay. As I told you, it's point C, right here. So let's apply this joint. I think you are following me, right? I don't want you to lost in thought. Be with me. We're almost done. So let's go to the front plane. Here we have this. The same thing happens here. Let's increase the size of the arrow. 500. How much was it? 50 kilonewton, right? So this is 5, 1, 1, 1. 4 zeros. Reverse the direction. Done. This is just simple, right? You don't have to make a lot of calculations. I know you have to understand the science behind this, but as long as you know how to solve it using SolidWorks, it's just simple. You can solve any complex mathematical structure. You want to know its bending force, its reaction force, or its shear and bending moment diagrams. So I think we're done, right? What else do we have? We're done. So let's solve. Let's run this. Let's go and run this study. This is the thing that we got, right? So first, let me show you this. Click results, right click, and let's go to this result for. We will try to know the reaction force at point B and at point D. So list, SolidWorks is asking us to select the joints where the reaction forces are located. This is the first one, right? And this is the second one, right? So let's update it. So as you can see, here we have 5.6 e the power of 4. What does it mean? It's 56 kilonewton. Here we have 2.4 is the power of 4. This one is 24 kilonewton. So as you can see, after the manual calculation, we also get the reaction here is 56, the reaction here is 24 kilonewton. So our simulation is correct. Yeah, we can easily conclude that our simulation is correct here. So let's proceed to this. This is the reaction force, right? One thing that I want to show is how you're gonna know or how you're gonna draw the shear force and bending moment diagram. Let's go here and let's right here there is define beam diagram. Right click. So here we have shear force, right? Let's go to the chart options and let's tell him to show us the minimum and the maximum. And the other thing is to make it more easy to read, let's plot the graph. What else do we have? That's enough. Let's right click. As you can see, we almost get the same result. But there is one thing that I want you to consider here. Here we have minus 30 kilonewton, here we have 26 kilonewton. But here we have the reverse, 30 and minus 26, right? What does it mean? Because in the manual calculation and in the SolidWorks simulation, there is different sign convention, right? So when we do manual, we use another sign convention, and when we do SolidWorks, we use another sign convention. So you don't have to worry about this. This is the exact thing that you get when you do it through SolidWorks. So let's see the shear. This is the shear. Let's see the bending moment diagram also. Here we have the shear force. Here we have, let's make the direction go and show as maximum and the minimum. Let's right click it. The same thing happens. Negative 48, right? 48 kilonewton. You don't have to worry about this. As I showed you, negative 40 and 48. You don't have to worry about this because it's about sign convention. They are just similar. Here we have 30, here we have negative 48.